We are looking at the phenomena of dispersion. So what is dispersion? Simple. We have white light falling on the prism and things refract within the prism and you get rainbow. You actually are looking at that. So there is sunlight falling on the prism, right, at this spot. Okay, I kept it dark at this end so that we can see the rainbow colors, because I don't have a very strong camera, right? So this is a setup, so you can see rainbow. So inside something happens. That's what we are trying to understand. So this phenomena is your dispersion. That's the definition. Again, we are taking up not a single wavelength light, but a white light. Remember, we studied about single wavelength light. Right? In first experiment, we looked at a single light, a light with a single wavelength. That is a single colored light. But here we are looking at a white light. So what happens? Within this, the red and the violet will look like this. And again, it gets refracted. Okay, so let me actually do it a bit properly. And you will see violet over there, red over here. And we have V, I, B, G. Okay, I'm not able to write it. So violet is bottom. Let me manipulate this a bit, because I want to write violet. Not violet, sorry, VIBGYOR. VIBGYOR. So that's your red, and it's get refracted this way. Okay, so this is your incident ray, white light, and this gets split into component colors. These are known as component colors. So visible spectrum. So this is your visible light getting split into visible spectrum. Okay, if not component colors. Right, so in between this we have everything, green and everything. So just let me do that as well. So in between is this. So this is what is happening. So let's look into the definition. When beam of white light is incident on a prism, the ray that emerges spreads out in a series of color known as visible spectrum. So this is your visible spectrum. This is your white light source. And this is your glass prism. That's your air. And this is the screen. The spectrum of visible light into its the separation of visible light into its different color is known as dispersion. Okay, a small note. These colors are always in order of decreasing wavelength. So starting from red to violet. Red has the highest wavelength while violet has the lowest wavelength. So this is always in decreasing order. Okay, so this is important for quite a few phenomena, to understand quite a few phenomena. Okay, so a small note on wavelength. Wavelength is nothing but length of the wave from one of the peak to the other one, if not from one end to this end, if not one trough to the other trough, somewhere over here, if not from here till here. Anyways, if it's a continuous wave, continuous sine wave, not cos wave, okay, of same wavelength, then any measurement will give you the same answer. Red will have a higher wavelength, means this length will be longer, while violet, so this is your red and this is your violet. Okay, so this wavelength is shorter and this wavelength is longer. Okay, so this difference we need to keep in mind. This is nothing but your dispersion of white light.